The Fibonacci sequence is a series of numbers where the following number is the sum of the two previous numbers. 0 and 1 is 1, 1 and 1 is 2, 2 and 1 is 3, 3 and 2 is 5, 5 and 3 is 8, 8 and 5 is 13, and so on and so forth. And while there is no way for this to be proven 100% accurate or correct, there are speculations that this sequence or some variable of this sequence acts as a key component to the expansion of the universe and everything that is a part of our universe. Now, before I lose you, I understand that this may seem like quite a stretch to say that something as simple as an ongoing series of numbers is directly connected to our existence in the world around us, but let me just graph out the Fibonacci sequence for you quickly. Let's just say we provide a box made of the area of each number. Now, we have a series of connected areas, but when you connect these points by connecting points from the areas we've drawn out using the graphing system known as the golden rectangle, the area quickly turns into what we refer to today as the golden spiral. Or when we divide these numbers, it turns into the ratio 1.618, also known as the golden ratio. Whether you're aware of it or not, we see this pattern and ratio in some way, shape, or form almost everywhere we go. In film and photography, implementing the golden ratio into the composition of a shot introduces a visual device known as the one-point perspective, or a way to make two-dimensional planes seem like three-dimensional planes. You'll see in this example, it's almost as if the framing of our protagonist is unraveling, just like, you guessed it, the golden spiral. We also can see the golden ratio take place more naturally as well. Let's say you have a sunflower, for example. The way in which the petals are blossoming outwards follows the golden ratio down to the exact digit in most cases. Most notably, however, you'll see the spiral pattern of the golden spiral in seashells. Okay, I know that I just threw a bunch of information at you guys. Let's take a quick look back at who Fibonacci was. Well, the Italian mathematician was born in 1170, obviously in Italy. He had studied numerical systems all around the world. I mean, Sicily, Greece, Syria, all over the place. In 1202, he had actually written a book called Liber Abaci, which loosely translates to Book of the Abacus. This was considered to be the first European work that focused on Indian and Arabian mathematical studies. This is actually also where the Fibonacci sequence was sort of discovered. It had come from a mathematical problem inside of the book that I'm going to paraphrase here because I don't have the actual text in front of me. But what the problem was basically introducing was the idea that if you were to have two rabbits and put them in sort of an enclosed space, put walls around them, and under the impression that for every pair of rabbits, for every month, they're going to birth a new pair of rabbits. Well, obviously the first month you'll have two, that's going to have another pair of rabbits, they'll have two, and so on and so forth. So this was sort of the introduction to the idea of an ongoing infinite number. Once you sort of take time out of the equation, that number will forever, ever, and ever be growing and duplicating, and that's where the Fibonacci sequence was birthed. No pun intended. In 1754, Charles Bonnet spent most of his time observing the outward growth of trees and plants, deducing their growth down to fractions that are found in the Fibonacci sequence. One of his biggest observations being that for every 5 branches that sprout off of an oak tree, roughly 2 rings around said oak tree grow. Okay, I know I just threw a bunch of information your guys' way once again. Let's take a step back and start to digest some of this. I use the term phyllotaxies. That's in Greek. It was coined by Charles Bonnet once again. All that basically means, it loosely translates to the leaf arrangement. Now there's just been this thing, this fraction, this equation called the phylotactic ratio. I'm going to put right there. If you look at that fraction on the right-hand side, you will see the Fn. The Fn is going to be a stand-in for the Fibonacci number that you're using at said time. It's going to be an infinite number. It's going to be ever growing. Now if you look at the bottom of that fraction, you will see Fn plus 2. That 2 is going to be a stand-in for the 2 rings that grow around said tree, with the Fn being the 5 branches that grow out of said tree. This is just in terms of the oak tree. There are different sort of fractions or equations that equal to like different plants, different trees, different leaves, but in this example we're just talking about oak trees. This is something that you really can look into, especially with the phylotactic ratio. The only thing is it's a very big complex, and this all comes back to a sort of theory that things grow in this pattern. This isn't going to be a blanket statement for every plant, but this is just sort of a loose representation of how plants grow and how it all connects back to the Fibonacci sequence, which I think is really cool. Needless to say, the Fibonacci sequence is simply the outward expulsion of energy. The few naturally occurring examples I previously mentioned don't even begin to touch the surface of the golden spiral sightings in nature. Look at the way a wave curls, a pine cone matures, a chameleon's tail winds up. The golden spiral is everywhere we look.